See, the new lesson is atoms. Here, first we are going to directly discuss with about Bohr's atomic model. In this, we are going to use three different laws in Bohr's atomic models. The first one is law of circular orbit. If you take one atom here, in any atom, if an electron is revolving around the nucleus having a charge Ze, the necessary centripetal force for this electron to revolve in this orbit is given by, so this centripetal force is mv square by r. This is provided by the force of attraction between the electron and the nucleus, that is 1 by 4 pi epsilon naught q1 into q2 by r square. So it's r and r get cancelled. So mv square is equal ze square by 4 pi epsilon naught r. This is equation 1. So from the law of circular orbits, that is necessary centripetal force is provided by force of attraction between electron and nucleus. So this is called a law of orbits, and from this we got mv square equal z square by 4 pi epsilon naught. Now the second one, law of stationary orbit. Whenever electron revolves in a circular orbit, its speed remains constant. Its speed remains constant here, but velocity changes its direction. Magnitude of velocity remains constant, but direction of velocity changes. As velocity is a vector, as the direction changes, we can say that this electron is accelerating. But we know that accelerated charge always produce electromagnetic waves, and it radiates energy. But according to law of stationary orbit, as long as this electron revolves in a particular orbit, as long as electron revolves in a particular orbit, it does not radiate energy. It does not radiate energy. That means energy of this electron when it is revolving in a particular orbit remains constant. So energy of that orbit or energy of the electron in a particular orbit is constant. But according to that electrodynamics, that is in electrostatics as well as current density, moving charges, magnetism matter, as well as electromagnetic induction and AC circuits, including this electromagnetic waves, we studied that when a charge is at rest, it produces electric field. When charge is moving with uniform velocity, it produces both electric and magnetic fields. An axial charge produces and radiates energy. But here, axial charge is not producing or radiating this energy. That means this electron which is revolving in a particular orbit does not obey, electron does not obey the laws of electrodynamics that we studied in the first part of our second year PUC syllabus. Now the third one is law of quantization of orbital angular momentum. The angular momentum of electron is given by, we know this one, mvr is equal to integral multiple of h by 2 pi. So this is the angular momentum which is equal to an integer value, and this h is a Planck's constant, 2 pi also constant. So angular momentum of electron revolving in a particular orbit remains constant. So from this m square v square r square is equal n square h square by 4 pi square. So this is equation 2. Now let me divide equation 2 with equation 1 here. Equation 1 is mv square is equal to z square by 4 pi epsilon naught. Here m square v square r square is equal to n square h square by 4 pi square. Now divide equation 2 with equation 1. So what we will get? Equation 2 is m square v square r square is equal n square h square by 4 pi square divided by, what is the first equation? mv square is equal ze square by 4 pi epsilon naught r. Cancel this v square and v square here. This is m and m here, and the remaining terms are, we have m r square here. So from this equation I am going to write m r square is equal m r square is equal n square h square by 4 pi square. This z square by 4 plus naught will become 4 pi epsilon naught r by ze square. Here this 4 and 4 get cancelled, pi and pi get cancelled. R square is equal n square h square epsilon naught r by this m pi m ze square. So what is r here? R is equal to this r and r also get cancelled here. Then you will have epsilon naught n square h square by pi m ze square. This is the radius of this one orbit in which this electron is moving. So this is the radius. So after finding the radius, here you can see epsilon naught is a constant, h is Planck's constant, pi constant 22 by 7, m is mass of electron, e is charge of electron. So radius of any orbit is equal to some constant into n square by z. That constant is known as r naught, which is equal to Bohr's radius, that is the radius of the first orbit of hydrogen atom. Radius of first orbit, if z is equal to 1 here. So now what are the ratio of the radii of the different orbits in hydrogen atom? For hydrogen atom, that is for z is equal to 1, this is equal to n square into n1 square into n2 square into n3 square, that is 1 square into 2 square into 3 square and so on. So r1 is to r2 is to r3 so on is equal to 1 is to 4 is to 9 so on. So this is another important formula for radius of the nth orbit. Now after finding this radius, now we can find out the kinetic energy. Here we have mv square, but what is the velocity of this one? To find out the velocity, first of all, if you know the r value, we can find the velocity. So to find the velocity, I am going to write the first equation, mv square is equal to ze square by 4 pi epsilon naught, r is equal to epsilon naught n square h square by pi m ze square. Now you cancel pi and pi. Here we can cancel m and m also. V square is equal z square into z square. So this is z square e power 4 by, this is 4 epsilon naught square n square h square. V is equal to square root of this one, you will get ze square by 2 epsilon naught n h. So this is the velocity of electron in the nth orbit. In this equation, we can see velocity directly proportional to if z by n. For a given hydrogen atom, we know the z is equal to 1. So velocity inversely proportional to n for a given atom. So from this we can write v1 is to v2 is to v3 and so on is equal 1 by 1 is to 1 by 2 is to 1 by 3. So 1 by 1 is to 1 by 2 is to 1 by 3 and so on. Now, for hydrogen-like atoms, that are atoms or the ions having only one electron, ions having only one electron, we can apply this Bohr's formulas, the formulas given by Bohr's atomic model. So just now we derived the radius of the nth orbit in the hydrogen-like atoms is given by epsilon naught n square h square by pi m ze square. This is the first equation. So this is Rn, radius of nth orbit. Then we found this velocity of electron in nth orbit, which is given by ze square by 2 epsilon naught n h. So this is the velocity here. Now if you take for hydrogen atom, for hydrogen atom, this equation for H atom, where Z is equal to 1, this will become R1 is equal to epsilon naught n square, n is equal to 1 because R1 radius of the first orbit by pi m Z square. All are constants value. This is 8.8 10 minus 12. N is equal to 1. H is equal to 6.6 34. Pi is equal to 20 by 7. M is mass of electron 9.1 10 minus 31. Z is equal to 1 for hydrogen atom. E is equal to 1.619. If you put all these values, you will get 0.53 angstroms. And this is called Bohr's radius. That is radius of hydrogen atom, radius of the first hydrogen atom, first orbit of hydrogen is called Bohr's radius, which is equal to 0.53 angstroms. That is 0.53 into 10 minus 10 meters. Similarly, if you take for hydrogen atom only, if you take the electron that is revolving in the first orbit, so velocity in the first orbit is given by Z is equal to 1 for hydrogen. Here Z is equal to 1 for hydrogen. E is equal to charge of electron, 2 epsilon naught is permittivity of free space, n is equal to 1 as I am finding velocity of electron in the first orbit, H is equal to Planck's constant. If you substitute these values, you will get C by 137 meter per second, where C is the speed of light, 3 into 10 power 8 by 137. So this can also be written as 300 by 137 into 10 power 6. So speed of the electron in the first orbit of hydrogen atom, this will be nearly 2.18 into 10 power 6 meter per second. So the electron in the first orbit of hydrogen atom revolves with a speed of nearly 2.2 into 10 power 6 meter per second. So after finding this R and radius and velocity, now we can find out for an orbit here, this is the orbit in which electron is revolving with a radius r with a speed v here. So now we can find the kinetic energy of this electron. Ke is given by half mv square, half into m into velocity is z square by 2 epsilon and h. Squaring this one, you will get z square e power 4 by 4 epsilon naught square n square h square. So the kinetic energy is given by m z square e power 4 by 2 4s are 8 epsilon naught square n square h square. So this is the kinetic energy of the electron that is revolving in that orbit. So after this, we can find out the potential energy of the electron. So potential energy of the electron is nothing but the system. Here we have ZE, which is positive, and electron has negative charge. So the potential energy between two charged particles is given by 1 by 4 pi epsilon naught product of the charges by distance between the two charges. So PE is given by 1 by 4 pi epsilon naught ZE into minus E by R. But what is the R here? R value you can substitute this epsilon and square by pi and Z square. So this can be written as Z E square, which is negative by 4 pi epsilon naught. R is equal to epsilon naught n square h square by pi m Z square. Now you can cancel this pi and pi here. Then you will write minus m z square e power 4 by 4 epsilon naught square n square h square. This is the potential energy here. So after finding this Ke and Pe, now we can find out the total energy of the electron which is revolving in the circular orbit. So total energy is given by Te is equal Ke plus Pe. So total energy is equal Ke is equal to m z square e power 4 by 8 epsilon r square n square h square. Pe is equal to minus m z square e power 4 by 4 epsilon n square h square. So in these two, m z square e power 4 by epsilon r square n square h square is common. So I am going to take m z square e power 4 by epsilon r square n square h square common, and remaining terms are 1 by 8 this is 1 by 8 minus this is 1 by 4. So the total energy of electron is given by this 1 by 8 minus 1 by 4 will become minus 1 by 8 minus m z square e power 4 by 8 to epsilon naught square n square h square. This is the total energy of electron that is orbiting in any circular orbit for an atom. So here you can see Ke is to Pe is to Te is given by the ratio of the energies is given by, you can see Ke m z square e power 4 by 8 to epsilon naught square n square h square. Total energy, you will get the same expression, but this is positive, this is negative. So kinetic energy, let us say this is 1 and the total energy will be minus 1 here. And if you multiply this with the 2 here, this 2 ones to 2 4s, the minus remains as it is, then this is nothing but a potential energy. So this is minus 2. So this is the ratio of the kinetic energy, potential energy, total energy of electron that is revolving in an orbit. So now we found radius, velocity, kinetic energy, and this is a potential energy of electron. After that we have total energy, and now we will find the time period of this electron to revolve in this orbit. So time period is given by T is equal to 2 pi r by V, which is given by 2 pi. V is equal to ZE square by 2 epsilon naught NH, and the radius is equal to epsilon naught n square h square by pi m ZE square. So the time period of this one is given by, now this will go up to, so this is 2 pi epsilon naught n square h square by, when it goes up this will become ZE square pi m ZE square, this will become 2 epsilon naught NH. Now what you can cancel here? You can cancel this pi and pi here. This time period will become, this 2 2's are 4 epsilon naught square n cube h cube by m into z square e power 4. So this is the time period of the electron that is revolving in this circular orbit. From this, what are the constant? 4 is a constant, epsilon constant, h constant, m z e constant. So T directly proportional to n cube. So T1 by T2 is equal n1 by n2 whole cube. So if you know the orbital number or principal quantum number or number of the orbit, you can find the ratio of the times taken by this electron to complete one revolution. So after this, frequency of revolution is given by, frequency is nothing but 1 by time, which is equal to m z square e power 4 by 4 epsilon naught square n cube h cube. So from this frequency we can write f inversely proportional to n cube here. So now whenever a charge is moving in this one, when the electron is revolving in this one, we can say, so current is passing through this one. So what is the current that is passing through this one? Current I is given by charge by the time period. Charge is equal to E, and the time period here we have 4 epsilon naught square n cube h cube m z square e power 4. So this is equal to m into z square into e power 5 by 4 epsilon naught square n cube h cube. So current equation is given by this value here. So in which orbit current is more? So if orbit is given, then current inversely proportional to n cube. So whenever n increases, current decreases. So after that, when a charge or current is flowing in a circular orbit of radius r, the magnetic moment of this magnetic induction is given by B is equal to mu naught Ni by 2r. So because the current is flowing in the circular orbit, so magnetic field induction is given by mu naught number of orbit by 2 into, this is r, I by r. I is equal to m z square e power 5 by 4 epsilon naught square n cube h cube into this r. You have to write r here when it goes up. R is equal to epsilon n square pi m z square. You can write this as pi m z e square by this r value epsilon naught n square h square. Now what you can cancel here? This is a b is equal to this 2 4s are 8. The denominator will become, and numbers that can be cancelled here, where n is the number of orbit, number of electrons. I will take this n as 1 only, because this is not the number of the orbit, this is number of electrons that are revolving in this one. So mu naught by 2, this will become, mu naught is constant here, pi is a constant. So pi m square z cube e power 7 mu naught by 8 into epsilon naught cube n power 5 h power 5 here. So this is the magnetic field induction of this electron that is revolving in this orbit. Here, for given hydrogen atom, you can substitute z is equal to 1. But here you can see frequency inversely proportional to n cube or time period directly proportional to n cube if z is constant, which is equal to 1. For other atoms which are having, other ions which are having only one electron, the z value changes, then this t can be written as t directly proportional to n cube by z square. Then we have to substitute z value also. Similarly for frequency also, this is for hydrogen atom, frequency directly proportional to n cube, but for other atoms, for other ions, directly proportional to z square by n cube. Similarly for current also, I directly proportional to z square by n cube. For hydrogen atom z is equal to 1, then current is equal to n cube here. What about the magnetic induction? So magnetic induction here you can see this is z cube, this is n power 5. All other constants, all other values are constant. So magnetic field induction of an hydrogen atom or other ions is directly proportional to z cube by n power 5. So after finding this magnetic field induction, we can find out the magnetic moment also in this case. The magnetic moment is given by magnetic moment, as current is passing through this one. So it will act as a magnetic field here. The magnetic field will be produced along this axis, and which is acting along this direction. So the magnetic moment is given by m is equal to current into area, actually NIA, but n is equal to only one electron. I is equal to, already we found this value somewhere here. This is m z square e power 5 by this 4 epsilon naught square n cube h cube into what is I? I is the pi r square value. So pi into r is equal to epsilon naught n square h square by pi m z square. R square will be epsilon naught square n power 4 h power 4 by pi square m square z square e power 4. So now you can cancel this pi and pi here. So magnetic moment is given by, in this equation, what are the values that can be cancelled? M and M get cancelled here. This z square and z square get cancelled. E power 4 and e power 4, this e get cancels. Epsilon naught square will get cancels. Now n cube and n square get cancels. H cube and h get cancels. This will be e n h. E n h by 4 pi m. So this is the magnetic moment of this orbit here. So for hydrogen atom, as we know that this n is equal to 1, so magnetic moment is given by E h by 4 pi m. This can also be written as E by 2m into h by 2 pi. You can see this is a nh by 2 pi. If n is equal to 1, then you can write the magnetic moment as E by 2m into angular momentum of electron of the first orbit. So this m by L is equal to E by 2m is a ratio between magnetic moment and angular momentum of the electron. So this is equal to E by 2m, that is equal to half of the specific charge of electron. 1 by 2 into charge of electron mass of electron, half of the specific charge of electron, and this is also constant. If the energy is defined as U is equal to minus k E square by r cube, find the radius of the nth orbit. So this is the total energy here, but we know that U is equal to, the force is given by negative of the derivative of the total energy with respect to the distance. So for any conservative force, F is equal to minus du by dr. So what is the force here? Minus d by dr of minus k e square by r cube. So this will become minus of this minus k, which is constant, bring it outside, and E is the charge of electron, which is constant, d by dr of 1 by r cube here. So this minus minus will become plus. This is k e square. This r, this is derivative of r power minus 3. So this is k e square. This will become minus 3 r power minus 4 here. So minus 3 k e square by r power 4. So this is the force. The magnitude of force is given by 3 k e square by r power 4, which is equal to, this will provide the centripetal force, which is equal to mv square by r. Here r and r get cancelled. So this you can write mv square is equal, mass into square of the velocity is equal, this is equal to 3 k e square by r cube. Now this I will take it as equation 1. To find out the radius here r is not present, here r is present here, but I need to use the angular momentum of electron, which is equal to mv is equal to nh by 2 pi, where n is the nth orbit here. So from this we can write m square v square by r square is equal nh h square by 4 pi square. So let me take it as equation 2. Now divide equation 2 with 1. So this will be mv square r square by mv square is equal n square h square by 4 pi square by 3k e square by r cube, or r cube by 3k e square. M and m get cancelled, v square get cancelled. This r square is equal n square h square r cube by 12 pi square k e square. This r square r get cancelled. From this r is equal 12 k pi square e square by n square h square. This is the radius of the mth orbit. You can substitute the 10 value here. Total energy of electron in the nth orbit is given by, so this I will write energy of total energy of electron in the nth orbit. So T I am writing is E in the nth orbit is given by minus of m z square e power 4 by 8 epsilon naught square n square h square. So in this let me substitute minus, this is 9.1 into 10 power minus 31. Z square you keep it like this, because from atom to atom z value changes. E is equal to 1.6 into 10 power minus 19 whole power 4 by 8 into, this is 8.85 into 10 power minus 12 whole square. This is n square constant, 6.62 into 10 power minus 34 whole square. Now here only this z square and n square varies from atom to atom, but for any atom this m, e, a, epsilon naught and h remains constant. So by substituting all these values you will get this in joules, but as we said this is atomic physics, generally energy will be measured in electron volts. So we know that 1 electron volt is equal to 1.6 into 10 power minus 19 joules. As we are getting in joules, divide this with 1.6 into 10 power minus 19 here, you will get this value in electron volts. Now by calculating this value, we will get minus 13.6 into z square by n square electron volts. So this is the energy of the electron in the energy of electron in the nth orbit of any atom. For hydrogen atom, Z will become 1. For first orbit, N is equal to 1. So for H atom, we will get Z is equal to 1. So what is the energy of electron in the first orbit? This is given by minus 13.6 into 1 square by 1 square minus 13.6 electron volts. This is the energy of electron in the first orbit. What is the energy of electron in the second orbit? minus 13.6 into z is equal to 1 square by 2 square. This will become minus 3.41 electron volts. Now, energy of electron in the third orbit is given by minus 13.6 into 1 square by 3 square 9, minus 13.6 by 9. This will be minus 1.51 electron volts. Now, energy of electron in the fourth orbit is given by minus 30.6 by 1 square by 5 square 25 minus 0.85 electron volts and so on. So, these are the energies of electron in the different orbits. Now, we can say whenever electron is revolving in a particular orbit, so this is the nucleus of this one, hydrogen atom. Now, this is the first orbit, second orbit, third orbit and so on. So, energy increases from one point to another point. Here 13.6 minus 3.4, as it is negative, so energy increases in the second orbit, third orbit increases. So, this energy increases as you move from first orbit to second orbit, second to third, third to fourth, like this. So, if an electron is revolving in a particular orbit, when if it jumps from one orbit to another orbit, only sufficient energy is supplied externally by using any other method, by supplying heat energy or light energy or mechanical energy. So, here the electron which is orbiting in the first orbit jumps to the second orbit only if sufficient energy is supplied in this one. But this electron will stay there in the higher energy orbit only for a fraction of second, nearly 1 nanosecond only. So, after staying for a nanosecond, once again it jumps back to its original orbit, and during this time it loses energy. That lost energy will come out in the form of radiation. So, this radiation energy. Now, this orbit I will take it as En1, and this orbit energy of this higher energy orbit. Now, whenever electron jumps from higher energy orbit to lower energy orbit, then what happens? It loses energy. So, that last energy I will write it as delta E, which is equal to energy in the second orbit minus energy in the first orbit. So, this last energy will come out in the form of radiation having some frequency mu or wavelength lambda. So, this energy difference is given by h nu, which is equal to what is the energy of electron in the nth orbit. So, I will write this equation minus m z square e power 4 by 8 to epsilon r square n2 square h square minus m z square e power 4 by 8 to epsilon r square n1 square h square. So, here what is constant? The constant terms are m z square e power 4 by 8 to epsilon r square h square constant, minus of minus will become plus. This will become 1 by n1 square minus 1 by n2 square. So, this h nu can also be written as hc by lambda, which is equal to m z square e power 4 by 8 to epsilon r square h square 1 by n1 square minus 1 by n2 square. Now, you can bring this hc here. If you write h here, it will become h cube, this c here c. So, this is 1 by lambda. The 1 by lambda is also called wave number. This is called wave number here. And mu bar is equal to this much, and this is a constant. And now you can write this 1 by lambda r into 1 by n1 square minus 1 by n2 square. So, where r is equal to 1.018 into 10 power 7 here. This is r z square, because z is also we have to bring it outside. So, for hydrogen atom you can take z is equal to 1. So, now this is the transition of electron from one orbit to another orbit. During this it emits different wavelengths or different frequencies. So, from this let me explain hydrogen spectrum. Hydrogen spectrum, this is the first orbit, second orbit, third orbit, fourth orbit, fifth, sixth and so on. And for infinite orbit energy will be 0. So, all these energies are negative here because these electrons are bounded to the nucleus. So, for bounded system energy is always negative. Here for Lyman series, what is this Lyman series? Electron in any high range orbit, when it jumps to first orbit, then we will get a Lyman series here. And the Lyman series wavelength also we can find for particular member. This is the first member of Lyman series when electron jumps from second orbit to first orbit. So what is the energy difference here? This energy minus this energy. So this will be around 10.2. So for this particular transition, when electron jumps from second orbit to first orbit, E is equal to h nu here. So that is also equal to hc by lambda. Energy 10.2 electron volts. This is equal to hc by lambda. So the hc is equal to 12,400 by lambda in angstroms. So from this you can find out this is around 1,241. So this wavelength is nearly 1241 angstroms. So this is how we can find out the wavelength of the radiation that comes out when the electron jumps from second orbit to first orbit. So this is the wavelength range. And similarly for infinite to the first orbit, that is called series limit of Balmer series, where you can write this value 1 by lambda is equal to, we can write 1 by lambda is equal to this r into z square, this r into 1 by 1 square minus 1 by infinite square. So 1 by lambda is equal to r, lambda is equal to 1 by r, that is 1 by 1.0 into 10 power 7. So this is the wavelength here, wavelength of the electron that is transferring from in. This is also called series limit, which comes nearly 912 angstroms here. So what is one by series limit? If electron jumps from infinite orbit to the particular orbit, first orbit in Lyman series, this is called series limit. Similarly for Balmer series also, this is the first member. This is also called H alpha line, H beta line, H gamma line, H delta line. So for H alpha line, transition is from 3 to 2. For H beta line, transition is from 4 to 2. H gamma line, transition is 5 to 2. H delta line, transition is from 6 to 2. So this wavelengths, when the electron jumps from here to here, here to here, from higher orbit to second orbit, the wavelengths will be in the visible range. This is between 3,800 to 7,800. That's why this is also called a visible spectrum or visible series. Now this is under this one. So this is in UV region. This is in infrared region. This is also wavelengths are in the infrared region.